How can you classify the principle and mechanisms of drug action? What are the different processes involved in this particular regard? And what is the role enzymes playing as far as the mechanism of drug action is concerned? Let me state the complete rigmarole in today's episode. We are actually in the shallow waters of the topic, and the fun lies in going across ripple by ripple till we master the big waves strongly enough to dive in deep. Why wait? Let's actually break the ice. Welcome all to Is Pharmacology Difficult podcast. I'm your host, Dr. Radhika Vijay, MBBS MD Pharmacology, and this is the audio hub to get the best simplified basic tips, strategies, methods, and lots of ideas to learn better, understand better, and make your concepts crystal clear. If you really find, and if there's a question hovering in your minds, is pharmacology difficult? Lend me your ears for a while and let in the magic of knowledge. Yes, we are on our way of pharmacodynamics. Generally, the drugs show both beneficial and harmful effects. They interact with targeted molecules. These special targeted molecules are called receptors. Yes, receptors is a very famous term as far as the subject pharmacology is concerned. Via the process of signal transduction, the drug receptor complex, it introduces many changes in the molecular cell activity. Principle of drug action can be actually of many types. The first one I want to comment upon is the term activation. Well, you can take it as a little sort of revision from the last episode. When binding of drug to receptor occurs, in fact, it progresses the drug action or the process. And this is what I refer to as the term activation. And very good example, rather a sort of a famous example, is caffeine stimulates the central nervous system and makes one alert. What can be the opposite of activation? Surely it is the inhibition. Binding to the receptor, in fact, hampers the drug effect or the process. And one good classical example I want to comment here is aspirin, that inhibits cyclooxygenase enzyme, and further in turn it inhibits the formation of prostaglandins. Next, let's talk about complexation. Binding of drugs to receptor when leads to the formation of a complex, and further the inactivation pursues. A very good example to quote here is deferoxamine, that chelates the iron, and that too by forming a complex. Lastly, a word about neutralization. Binding of drug to the receptor neutralizes the existing action simply via a chemical reaction, and very good example is of antacids, which neutralize the acid production in the stomach. Now, when we direct ourselves to learn about the mechanism of drug action, then what we need to know most importantly is that drugs may act by receptor mediated or sometimes non-receptor mediated mechanisms, or simply by targeting specific genetic changes. Most of the target molecules, they are made up of proteins. I repeat, most of the target molecules, they are made up of proteins. And that is why they are so selective in nature. Well, that's really very important thing if you pay attention. Talking about the functional proteins, they are mainly of 4 types. They can be enzymes, they can be ion channels, transporters, and are very well known receptors. First, I will be commenting on the enzymes. Enzymes are very important protein molecules and they serve as the targets for the drugs. increase or decrease in enzymatic functions. It is achieved by the drugs. Enzymes can be stimulated through the receptors and sometimes what we label as the second messengers. Well, you might be wondering what is this term second messengers. Don't get caught into this. This term will be discussed and understood in a much better way very, very soon. Well, that was the teaser I gave you. Let's continue. Enzyme stimulation increases the affinity for substrate and the reaction rate constant, which we generally refer to as small k capital M, it is lowered down in the value. I hope you're getting what I'm trying to convey to you. In a nutshell, the affinity increases and the rate constant value is lowered down. Got it? These are the two important points related to the term enzyme stimulation. Okay. Now I will be making you familiar with term enzyme induction. And another one opposite to that is what we call enzyme inhibition. Now, when I talk about enzyme induction, it refers to more production of the protein moiety of the enzyme. And that in turn leads to the increased enzymatic activity. But very importantly, don't miss this term with enzyme stimulation. And now I'll let you know the differences between the enzyme stimulation and enzyme induction. I told you enzyme stimulation leads to two important processes, increase in affinity and the value of the rate constant is lowered down. What happens in enzyme induction? In case of enzyme induction, the rate constant of the reaction, it does not change at all. Yeah, the value is not changed. It remains the same. So, you cannot use the terms simultaneously, synonymously, they are different. I hope you understand. Now let me enlist some of the drugs which actually act as enzyme inducers. Drugs like anticonvulsants, namely phenytoin, phenobarbital, carbamazepine, etc. Then we have drugs rifampicin, glucocorticoids, isoniazid, chronic alcohol consumption. Some of the industrial pollutants may also help in enzyme induction. Then omeprazole, griseofulvin, nevirapine, and smoking also induces enzymes. Now with this list, let me withhold my words for the day. I promise to elaborate this set of colloquy and especially the heading enzyme inhibition in the upcoming verbal session. Well, that's actually too much to talk, and why lose the essence of such an important topic just for the sake of few minutes? No, that's not right, okay? For all the updates and latest episodes of my podcast, do visit www.pharmacologydifficult.com, where you can also sign up for a free monthly e-newsletter of mine. It actually contains a lot of updates about medical sciences and drug information updates. And my podcast updates also. You can follow me on different social media handles like Twitter, Insta, Facebook, and LinkedIn. They all are with the same name as Pharmacology Difficult. If you are listening for the first time, do subscribe and follow whatever platform you are consuming this episode. Stay tuned. Do rate and review on iTunes, Apple Podcast. Stay safe, stay happy, stay enlightened. Thank you.